Hello everyone. In this video, I'll discuss the velocity triangle of an impulse turbine and the construction method of solving the numericals of impulse turbine. So, I'll draw a rough velocity triangle first, then I'll start using the construction method for drawing the exact triangle. So, the velocity triangle can be drawn like this. So this is a straight line, assume so, because I'm using a touch panel for drawing the lines. This is alpha, this is theta, this is CF I, CF naught, this is CI, this is CRI, this is CBL. CBL is this much only. This is CWI. Then this is CR naught. This is C naught. This is CW naught. Then this whole is known as CW. So this is the triangle. Let us give some names to the edges. So A, B, C, D, E and F. So this is the velocity triangle, but for this I have missed these phi and beta. So this is a triangle which we'll draw in rough. Whether we'll use analytical method or we'll use the construction method, we have to draw such triangle in the rough so that we can understand that what are the things which are given, and by using the trigonometry and triangle laws and Pythagoras theorem, etc., what can we find. So let us take some data randomly. So this is CBL. Let us take it as 200 meter per second. And this CI as 500 meter per second and alpha as 20 degree. So now I'll take some scale for drawing the triangle. So let us take the scale as 100 meter per second is equal to 1 centimeter. So for drawing the triangle, we'll take the scale. So as we know that CBL is equal to 200 meter per second. Fine. So we'll draw a straight line, horizontal one, because this is CBL. This is CBL. So we will draw CBL first. So this will be a straight line of 2 centimeter. Then we will draw this nozzle angle. So the nozzle angle is 20 degree. So we'll take a compass, we will draw 20 degree angle, and like this we will draw a random line, the length of which will be marked using a protector, and the length of the line will be CI will be 500 meter. So the length of the line will be 5 centimeter. We will be cutting an arc of 5 centimeter on this line. So we got this CI, this alpha and this CBL. Now as we can see that by joining this point, the end of CBL on the right hand side and the end of CI on the right hand side only, we can obtain this line CRI. And by let us first draw this CRI. So this joined by this will be CRI. So now when we'll draw a perpendicular from A to this, we will obtain the point B. So this is a straight line, and let us extend this CBL line. So we will obtain point B. So from this is what is obtained as the inlet velocity triangle. So this is CAI, this is CRI, this is CFI, this is CBL already drawn, this is alpha, this is theta, and this is CWI. So Now as we have obtained this triangle, so by measuring the length of this, so we will obtain CRI. By measuring the length of this, by measuring the length of this B to C distance, we can have the distances, and further by multiplying the distances by 100 we can have the velocities CFI, CRI and CWI, and we can also have this distance B to C, and by measuring this angle we can have the blade angle at inlet theta. So now in the question it will be given that rather if the blades may be equiangular, or like in one of the questions it was given that phi is 3 degree less than theta. So any relation will be given, and by using that relation let us take them as equiangular. So I have already identified theta, so I can draw phi here at an angle which is equal to theta if the blades are equiangular, and this line is drawn randomly at the phi angle. The length of the line is random, so this is phi. Now the length of this line will be decided on the basis of the data given in the question about the smooth blades or friction is present in the blades. So if the friction is there in the blades, then the velocity coefficient is given, and we can have Cr naught upon Cri as the velocity coefficient. But if it is not given and the blades are mentioned as smooth, or nothing is mentioned in the question, then we'll take Cri is equal to Cr naught. So let us take smooth blades only. So Cr naught will be equal to Cri, and hence we will measure this Cri from here, the length of the line, this one, and then we will take a compass and then we will put an arc here. So like this we obtain the point F. So when F is obtained, the CO can be obtained by joining the left end of CBL to this point, and by drawing the perpendicular in the similar way as used in this, we will obtain CWI and CF naught. So what we'll do, we will join these two first, then we will drop a perpendicular here, then we will extend this line, and we will have the whole outlet velocity triangle. We can measure beta, we can measure CW naught from here, CF naught from here, C naught from here. So now we have all the data of the velocity triangles, inlet and outlet both, and by using such a method will be known as construction method, and by knowing all the velocities we can have blade efficiency, stage efficiency. Then obviously for the stage efficiency we need to have the nozzle data too, and the work done, axial thrust, power developed, everything can be calculated using this data. So this was all about the velocity triangle and the construction method of solving the questions on velocity triangles. So thank you so much. We'll discuss the questions further in the upcoming videos. Thank you.